Welcome back. This is an Aleks homework video on using Avogadro's number. Avogadro's number is a very big number, but it's used a lot like the word dozen. 1 dozen of something is equal to 12 of those somethings. So a dozen donuts is equal to 12 donuts. A dozen eggs is equal to 12 eggs. An Avogadro's number, okay, is used like a dozen. Avogadro's number is like the number 12. It's a large number. It's 6.02214 times 10 to the 23rd of something. Okay, so that would be 6 with 23 zeros. Okay, or 6.02214 and 18 more zeros. So it's an enormous number. But it's like a dozen. It's just a number. Now, a dozen is the word for 12 of something. The word for this many, Avogadro's number of something, is called the mole. 1 mole of something is 6.02214 times 10 to the 23rd of those somethings. So they're giving you a problem here. A virus has a mass. It's a tiny, tiny mass. 1/1000th of a milligram. And a milligram is 1,000th of a gram, and a gram weighs about the size of a raisin or a paperclip. Okay, so this would be 1/1000th of 1,000th of a paperclip's weight. And that's what a virus would weigh. An oil tanker has a mass of 3.7 times 10 to the 7 kilograms. So that's 30,000 kilograms. No, 30 million kilograms. And a kilogram is about 2 pounds. So it'd be like 75 million pounds. All right, so they're going to ask you first, what's the mass of 1 mole of viruses? And then how many moles of viruses would it be equal to the weight of the oil tanker? All right. So let's find out. We're going to start with what we have. 9.0 times 10 to the minus 12 milligrams. Okay. And I'm going to say in 1 mole of these, it's going to be 6.022 times 10 to the 23rd of them. Okay, so if I want 1 mole of viruses, I want 1 mole times this weight. So I'm going to multiply 6.02214 times 10 to the 23rd, and I'm going to get a weight in milligrams. Right? So I've got 9.0 times 10 to the negative 12th times 6.02214 times 10 to the 23rd. Okay. All right, so that's going to be equal to 5.4199 times 10 to the 12th milligrams. They're asking us for grams. Okay, so I need to get rid of milligrams and find grams. Well, gram is bigger, so I'm going to put a 1 in for the gram. And there are 1,000, that's 10 to the 3 milligrams in a gram. So 3 of these cancels with 3 of these, leaving 9. So I'm going to have 5.4199 times 10 to the 9th grams. Milligrams have canceled, I'm now in grams. So that's what's here. 5.4. Now look, I've got 2 significant digits in my number, so I can't have any more than 2 in my answer. So even though my calculator says 5.419926, I'm just going to round to 5.4 times 10 to the 9 grams. Okay. Now, in order to find out how many that goes in, that's what 1 mole weighs of viruses. Okay, that's 5 billion grams. So I'm going to need to find out how many grams is in a kilogram. So let's take this and turn it into kilograms. So 5.4 times 10 to the 9th grams. And gram going to kilograms. Grams is on the bottom, canceling. Kilogram is bigger. That's a kilogram. That's 10 to the 3rd grams. Kilo is 1,000, so 10 to the 3 grams in a kilogram. The 3 is going to cancel 3 of here, leaving you 6. Okay. 6. And so I now have grams is canceled. I'm now in kilograms. So 5.4 times 10 to the 6 kilograms is how much that the 1 mole of viruses weigh. And viruses are tiny, tiny, tiny. But a 1 mole is so big that all those tiny things added up will give you 5 million kilograms, okay, which is like 10 million pounds. It's ridiculous, okay? It's still smaller than the tanker, so there's going to be some going into the tanker. All right, so we're going to say that the tanker weighs 3 times 10 to the 7 kilograms, and I'm going to divide the number of viruses into it, number of moles of viruses, divided by 5.4 times 10 to the 6 kilograms, and I'm going to have 5.55. I'm going to round to 2 significant digits because I've been given 2 significant digits. So that's going to be 5.6, and that would be how many moles of viruses would fill the same mass as an oil tanker. 5.6 moles. Okay, so I think this is showing you just how big the mole is. It's so big. If you were to cover the Earth in 1 mole of marbles, it would cover the entire surface of the Earth 2 miles deep in marbles. That's how much 6.02 times 10 to the 23rd is. It's ridiculously big. But when we're talking about something small like a molecule or an atom, it's the most useful that we can use. So I hope this helps.